Okay, so Susanne, thank you very much, Heiko, for having Katrin, Wolf, and me today here to talk about gaze tracking, gaze interaction. And what we do first, I'm honored to introduce our two guests, and then Katrin is starting with the first question. So on the slide, you have already Enkelejda Kasneci. She is a professor at Tübingen University, and she is really at the intersection of machine learning, signal processing, and eye tracking. And she has, if you look through the publications, there's a lot of really exciting work going from the very deep levels of how you build an eye tracking system all the way up to applications of eye tracking. And the second person we have is Hans Gellersen. He's a professor at Lancaster and also at, he's still in Denmark, but he may say a bit something about this himself. He has two affiliations at the moment, and he has done a lot of eye tracking research on the, how do we create interactive systems? How do we create a meaningful interaction with gaze? And when Katrin and I talked, we figured having those two people in one conversation, that's our dream team for talking about gaze interaction. And now here we are, they both said yes. And Katrin, do you have a question?
Yeah, so I do have some questions for Enkelejda and some for Hans, but I start with a probably like icebreaker or jump in. So we have this like project team on ubiquitous computing, and Hans and Albrecht like searched for this or investigated ubiquitous computing for ages, for decades. And I was wondering if gaze and eye tracking becomes ubiquitous, will this change the way we look or what we look at? And be happy to answer both who's first on the mic, and then probably you add to each other's answers.
Enkelejda, shall I let you go first?
Yes, sure. So, Katrin, thank you very much for this very first and nice question, and also thanks for the invitation here. I see there's a lot of people, even on a week, having school holidays in a lot of countries in Germany. It's nice seeing so many people here at 5 p.m. All right, so very nice question, and I have asked this question many times during experimental work that we have doing. As Albrecht mentioned, we in the group have been working along the whole eye tracking pipeline. So we've learned to, build all these eye trackers, think about positions, where do cameras feed best, which designs to use, how to capture the whole eye, or which parts of the eye do we need. And actually, when you wear these eye trackers and you start collecting the data, and by the way, there was a very, very nice study we conducted in a museum in Vienna with our collaborators from art history in Vienna. There was, we really did a systematic looking at this question, right? How does it change your viewing behavior, right? Wearing this type of eye tracker. And we figured out, at least in the study that we had, so we had this kind of a very ambitious goal of having every person who comes in just wearing an eye tracker going around and then look at the eye movements. And we kind of had a very fancy technical setup. We could nicely recalibrate our recordings, so we could let people really freely move in the museum. And capture very nice data. Then we figured out, okay, the whole data that we collect during the beginning, it's actually worth nothing because it takes the minutes in the study that we had, in the mean about 5 minutes, to forget that they are being observed. And this is something that is very interesting, right? From a user's perspective, what does it mean to be observed the whole time, right? We're talking about a lot of observation technology being around us, camera observations. And if it changes the way on how we look at things, I think partly yes, but we are also very good at forgetting that we are being observed. So we also quickly forget about things. And it is our duty as a researcher or as a product development leader to make sure that we do not run into this issue of, collecting data of users that are unaware of being, observed, or unaware of the fact that their data is kind of being used and processed. So yes, it changes the way you look, at least, partly.
Maybe Hans, do you want to add something?
Yes.
Yeah.
Yeah, no, I definitely want to chip in there. So because, in a way, any interactive technology is affecting how we look. So we, for example, now through the pandemic, our viewing distances have shortened substantially. Because we look a lot more at the short distance to our laptop. And all this is affecting, our visual systems. So I think that is really an important consideration for technology design in general, how we're really changing our perceptual abilities, visual abilities by the technology that we introduce. Now, with eye tracking in particular, of course, it's what Enkelejda explained is a very important phenomenon. We use eye movement the whole time, and our eye movement carries a lot of, deep social signals. Sort of we're jointly aware of what we're looking at. But on a very subconscious level, we are very rarely reflecting about what we're looking at. It just happens. So we have a very limited awareness over the agency of our eyes, over the effect we can have with our eyes. So Enkelejda has given great examples. I can give another one of a study my student Melody did 6-7 years ago, where she developed a virtual reality game with virtual characters that the user would interact with. And these characters would react depending on the player's gaze. And many of the participants in the study felt quite taken aback by sort of almost being shown, they were thinking of this as being exposed, in what they do with their eyes. So it can come as a kind of surprise when you're confronted with the effect your gaze has on others.
I think one interesting thing, what comes out is, for me, is this question: will we train people to use their eyes differently, to be socially acceptable? And I think I've sort of, one of my very first eye tracking experiences was, so we had an eye tracker and we had one of the example images that came with the device that you would probably not show nowadays to people, but it was a lightly dressed woman on a motorcycle. And you could really sort of, it was something we used it to try the thing out. It was 20 years back. So, and the interesting part was this really sort of what Hans said, you're not really aware where you look. Once you see the scan pass, you sort of figure out this is probably, others shouldn't see my scan pass. So it is private information in a way. And I think this is something we have learned it in other ways to disguise ourselves. But I think this is a question if once we make this ubiquitous, and I think there are examples having it in the classroom in other ways. Imagine you're in a classroom and you have the gaze of 20 students, 30 students over the whole hour. You may sort of infer a lot of information about who likes who doesn't like whom. So I think this is sort of the question, who should, is it a technology like face recognition where we need to really figure out whom we give access to? Or should we, as a state, regulate gaze basically access to gaze data?
I would have a follow-up question, and so Hans, I looked at your work on this like social gaze for immersive gameplay, which you just I think referred to, and I was wondering like natural language programming. So we know how to have to pose and to behave to have a certain impression on our people that surround us, and then Enkelejda, you did. You published a paper on differentiating like expertise level for surgery. And I'm wondering if probably in high cognitive load situation, we cannot control gaze, or if you really work with our eyes. And in some situation, we probably can a bit fake and I don't know, influence how we appear. I don't know, like these two works go a bit in the direction which we just talked about. So maybe you have an opinion on this.
Yeah, it's kind of maybe I can start on this one and also Albrecht's really. So Albrecht, your question was really on how privacy sensitive and how how in control of eye movement. There is we talk to situations where it can be embarrassing. What we look at, but the problem runs a lot deeper because our eye movement carries so much information about health, about so if you analyze eye movement over longer periods, you can draw a lot of inferences on there are links to mental conditions and so on. So it is really highly sensitive data, not only from the perspective of not wanting to be exposed, looking somewhere where we maybe shouldn't look, but really it is, eye movement can reveal so much about us as individuals, about our personalities, and I'm sure Enkelejda can tell us a lot more about this because she's also using very advanced techniques to conduct these analyses, using machine learning on eye movement signals. The other question that Katrin added, I think generally we don't really want to design systems where we have to make a cognitive effort concerning where we look. The beauty of our visual system is that it makes things easy that we otherwise have to concentrate on. We know the foundations of visualization. If a visualization is good, then we gain information without having to think about it, because we can see it, we can visually perceive it without cognitive effort. And so anything we do with our eyes should really be designed to avoid cognitive effort. And as we can think of examples where people would control their eye movement to exert an effect. The Ronaldo at the penalty kick looking the other way. It's kind of. But in general, in interaction design, we would of course want to avoid for users to have to control their gaze, avert gaze, or go out of their way, so to speak, with their eye movement. Sorry, Enkelejda, I was monologuing there.
That's fine. I was going along the same line as Hans, and also stressing a bit the point that Albrecht mentioned, that we have to be careful with this kind of user tracking or eye tracking bit, because I'm sure you all know in the round, there's a lot of biometric information contained in this data. That's why there's a whole community effort. And I specifically want to point out at this now, because it took a long time to understand that we need privacy preserving techniques for these kind of signals, right? So that, you know, we should do everything that it takes to keep the person's privacy, right? Because there's a lot of biometric information contained in the data. Plus, it will tell us a lot about our actions, intentions, you know, cognitive state, mental health state, everything that Hans already mentioned. And there's a lot of ways to use this technology in a very beneficial way. Maybe some of you in the round have heard about the AI for assistive technology, a program that Microsoft launched. I think it was 2 years back, where they have designed a VR-based training system that would help adults with autism to improve their social interaction skills. So there's kind of a tutorial system designed for, you know, personal usage. So there's no data sharing with others and so on, but will help, or would kind of, or has at least the ambition to help these people improve their social interaction skills, in the sense that they learn to look at others people's eyes, so they have a better communication flow and so on. So then we are at this point of utility versus privacy. So how much of my data actually feeds in somewhere and for what purpose? And we as a research community are in the duty of offering techniques on how to preserve the privacy of this signal, because it's a very sensitive signal. We mentioned it several times, that has to be dealt with very carefully. And I think it's a topic that the EU Commission is basically now addressing along the AI regulations, or the regulation framework that's coming for the AI. I think at this combination of AI with this behavioral data, there is a lot of things that require for further regulations as well, right? So where we have to be also very clear. And then, Katrin, I didn't fully get the question about the visual expertise that you basically spotted out of, you know, my work line.
Yeah. So I thought that you can recognize the level of expertise of a surgeon based on the eye movements doing their jobs. And this is very implicit, of course. This is probably not even an input. It's just like monitoring, I guess. And what I meant was that in such situation where you have high cognitive load, and yeah, I did not mean to require cognitive load as input, but you know, when you kind of read the gaze of people in a situation where you do something with high concentration, you cannot really control it, because you have totally to focus on your task. And I thought that there may be like a continuum, you know, in situation where I have nothing to do, I probably can control my gaze, which we do in the personal communication in a way. But in this situation which you investigated, I don't think that's possible at all. So it was a bit like a hypothesis that we, you know,
exactly.
To a certain extent we can control it.
I'm sorry. Yeah, I'm sorry. The internet connection is not very good. I don't know. Maybe on my end. Not sure. So I like to think of this. So the way we as humans interact with the world is multimodal, right? So we use several modalities to interact with our peers, and would like to use the same modalities basically to interact also with the devices, right? So I like to think, I mean, we're not there yet, but I like to think of using gaze as a very natural modality, not doing some extra effort or trying to learn things or to educate people on how to use their gaze with system. So, I mean, we know like every kind of interaction that doesn't feel natural to the user, or that helps the user to, you know, have a better experience or achieve better performance, or for any other purpose that the user would like to, that technology or that kind of interaction paradigm won't get accepted by the user on the long run or by the mass. So I think I like to think at least of eye tracking being just like a very natural modality, just like we as humans interact with each other. These things also being built up in systems.
So let me sort of ask here a bit deeper, because I think we had this discussion since probably 1995 when Rob Jacob had sort of a number of things on natural interaction with. And I supervised the thesis, I think that was finished 2007. And we said, oh, if full HD cameras are in the laptop, everybody will have eye tracking, and we will basically have eye tracking everywhere. And now we have basically technology-wise, every basically currently sold laptop can do really good eye tracking. We have the processing power. Our desktop machines, laptop machines, they are sort of idling most of the time. And hence, none of the eye gaze interaction is really in mainstream operating systems. So if you look at Windows, if you look at Mac OS, even on sort of, there's not a sort of a single Linux desktop where somebody said, oh, I put this in. So, and I think it has not happened. I think it happened a lot in the research community. We cite it a lot. So that's all good from a research perspective. But perhaps starting with you, because you just mentioned, what is missing? Why is it not happening? Why is it not getting out of the lab? Why is it stuck in the lab? Enkelejda, you had just sort of said sort of the basis. So what is your take on that?
Albrecht, would you like Hans or me started on this?
I think it was in my initial response to you, and then I think we can move the question. So please, sorry.
Yeah, so that is just one remark I want to do on this. I mean, I started my PhD sometime 2010 and 11, and that was exactly the paper I came across, okay? So Jacob and Karn, 2003, I think it was, eye tracking, is it ready to deliver the promises? And then what they stated in their paper, just, okay, where is the problems we're stuck with? It's technical problems with eye tracking, so technical problems not being able to see the eye of the user to infer the gaze vector, basically, or at a accuracy that would like to have it in a specific use case. Okay, it's a labor-intensive data extraction, and yes, this is still true. So we have a lot of tools around on how to extract all of the eye movements and a bit of scan path analysis, but we're not there yet on having a fully autonomous pipeline working everywhere for this kind of data. And there was, then the bigger issue, I think, that is still part of the research, difficulties in data interpretation. So this is the 3 levels of things where we are still struggling with, because data interpretation is, okay, by the moment we are there, having extracted all of the eye tracking data and trying to connect it to something, right? To some actions or intentions of the user or a cognitive state, then we are in a very task-specific setting. So we are within a very specific context for a very small specific task, something that will hardly generalize across other things that we'd like to use that for. So
let me take the other extreme. I think gaze pointing, one of the first things people did when they put gaze pointing, I think it would now work extremely well with my current laptop, with the processing power I have, with the lighting I have, with the machine learning we have. We could do gaze pointing on any system, or couldn't we? Because that's, I think, something, and gaze pointing, I think there were a lot of papers that said, oh, this is sort of so much more convenient, as Hans said, oh, it's so natural. We know there is sort of the Midas touch. We have some ideas. We get so basically, I could replace the mouse by just a button. So, but it hasn't happened. So we still on the laptop work with sort of the touchpad, which we know is sort of much worse than the mouse. So I think these are the things, and it just doesn't happen. Is it really that the technology is not working everywhere? Or is there sort of something that the interaction designers just didn't get it right? We have just not figured out how gaze pointing works, because I think sort of that would be my interpretation. I can do sort of I can get the pointer, but I have just no idea how to design the interactions. And even companies like Microsoft and Apple haven't figured it out.
Yeah. So there are, in my view, there are two sides to it. You know, for long, the technology, the tracking problem hasn't gone away. Yeah, we can have cameras everywhere and achieve eye tracking in lots of circumstances. But the problem is really just how amazingly individually different people are. Yeah, and so to find an eye tracking solution that works really for everybody out of the box, that is still not there. You know, that has to do with, different shapes of different faces, different heads, different eyes, wearing glasses, and many of those issues. So even with head-mounted devices, manufacturers struggle with camera positioning and really getting it right in a way that reaches really everybody. And that really stops. I think that's one of the reasons why we don't see it as, in laptop interfaces already widespread, because, for those kinds of systems, we can't afford to introduce technology that leaves out part of the population. Yeah. And so it is ready for adoption in niche areas where it can be made to work for people, but of course for anything like a laptop interface, also the expectation is entirely different. So there remains a huge technical problem that goes beyond different lighting conditions and so on, and just has profoundly to do with how it remains a hard problem. So I think that's still there, but I completely agree that the other problem is, of course, to find the right interaction model. And while gaze pointing intuitively sounds like an obvious thing, it was, people first started talking about it in the 70s for accessibility and so on. But our idea of pointing is, of course, shaped by the mouse, by the experience of a mouse that can be, where we can make, we can select pixels. We can nudge a mouse cursor. I can't nudge my gaze. I can look at something, but I can't nudge my gaze a little bit to the left or a little bit to the right. So there remain fundamental differences about the ways in which eyes select an object of interest versus how a mouse pointer does it. Yeah, and these differences aren't going away. So we need interaction models that are based around what the eye does and doesn't do.
Okay, so I think at this point we are half an hour in, so we would also open the floor to the audience who have questions. And we have already seen Shadan has put the hand up. And so we get you started, please.
Yes, hi everybody, and thanks for the nice discussion. I have one question following Albert's point about controlling people's gaze and where they look at. So ethically, it's correct, it's right to tell people that their gaze are being tracked while we are tracking it. But when we think about social context, when we tell people that their gazes are being tracked, they basically behave and they do not act as they would do in maybe their natural setup. So the question is that how to study such behavior about social acceptability and pro-social behavior with an eye tracker that despite being ethically correct, also are kind of externally valid.
I need to ask there. So, in what sense do you I need a bit more help there on
Yes.
to understand sort of your question.
So, for example, imagine working with robots or some kind of avatars together, and then you have eye contact, and this robot is your colleague, and then you feel kind of observed by an action, and you think that your also gaze is being controlled. And you might work with this robot. So like in case of, for example, robot bullying or bullying a so-called AI-based colleague.
Yeah, I think I understand where you're going. So it is just making people aware of that they are recorded, so that, you know, to gain kind of informed consent isn't really fully addressing the issue, because you're still you know, affecting what users feel they can do or can't do. So there are ethical questions beyond just being open and honest about surveying people. Yeah, because we don't really we don't understand the impacts. Yeah, the effects of what would it be like to live in an environment where we are constantly observed, even when we know and formally accept, sign the dotted line that the technology is there. Sort of how would it affect us, and is that acceptable? Yeah, that's not clear, and we're nowhere near to study that really. Yeah.
Thank you.
So you are still invited to have more questions, and I would add to the question, like, why is gaze not built in our devices? And one of the main or key principles for usability is this keeping the user in control. And we talked about the gaze pointing, and I saw in Ars Electronica 2008 like an installation where it was about like long press, like long gaze, and this clutch event is making us really slow. And then on the other side, we know that gaze only causes Midas touch. So what are your design guidelines if we want to do like gaze, and which modalities probably serve best for clutch events, or to distinguish between natural gaze and input? Maybe Hans, as your mic is on, do you have some guidelines? How would you design, like, you know, a usable gaze interface?
This is I mean, it really depends on the design context, but your general question is about how do we how can we know when a user, how can we infer intent? That's what it really is about, and that really depends on context. So in for for some tasks, like for example text entry, it can be we can design systems that are highly optimized to detect intent from gaze, and then we can develop great solutions for that. In other contexts, you know, there are many ways of addressing this with additional modalities. What I'm personally interested in is also the idea that you know, our eyes our eye movement is strongly coordinated with other body movements. Yeah, so when we talk about gaze, we always think of it as just something we do with our eyes, but when we gaze at something, then we do that through a combination of moving our bodies, moving our head, moving our eyes. When we interact in the world, it's rarely do we do that without guidance by our eyes. So there is a lot of interconnectivity between the different movements we make with our bodies, including the eye movement. And And so I'd like to think that if we understand the coordination better, that we can also draw better inferences about our intentions.
Perhaps I extend this to Enkelejda. You've done a lot with machine learning, and I think you pushed it over the last years massively forward, and I think a lot of the machine learning focuses on detecting the eye. But do you think we will see more in that direction also on the intent detection? Because I think that's one of the holy grail in a way beside. Do you see any chances that we get closer with the technologies we have at the moment, or would we need different data sets, or what would it take to really get to this discrimination between what is sort of intentional, what is just basically gaze we're doing because we do our jobs?
Yes, so thanks for the question, and it actually adds up very well to Hans' comment, right? So we always work in a very specific context, and there we have to do a task, and this task is not what we do with our eyes, is not dissociated from the world, the context, and the task itself. So it has, I think we can get to this intent if we know what the task is and what the context is. So that's why, so we have been a lot into this area of combining other information, combining information about the task itself, right? The semantics of the scene, what's happening around us, with gaze and other modalities, right? So I don't think, because it goes into the general AI problem. So we always come back to this kind of, general AI problem is, are we going to design a system that is able to capture users' intent? And then we have to break it down to a very specific question, like, can we do that for a specific task in a specific context? And that's why, so I think despite all the efforts that we're doing on having something that is somehow working in a screen-based fashion, I think that a lot of, eye movements, analysis, and, the use cases will be coming with the with their integration into VR devices, with AR probably, and also a lot of very specific use cases. For example, in automotive, there's been a lot of efforts on including eye movements to infer things that are happening or objects that have been overseen by the driver. So for very specific use cases, and I feel more comfortable thinking of this at a low level, like having for a specific task, trying to find their things. So we know there are features in the eye movements that generalize across tasks, right? So there's things that you can find out that are very good predictors for something that is, expertise, for example, or cognitive load. But even like cognitive load detection and research has been, done for 40 years, 50 years, and nobody has a method that is working across tasks and across subjects, right? It's very hard. So we have to get back to this individual, capturing for a specific individual task and context, and learning things about this individual in order to make the interaction, to make a good interaction.
Susanna had a question, I think, since some minutes. So yes, please, Susanna, ask.
Yeah, thank you very much. And for the very interesting discussion. Anyway, that's good to have you here. My question is, are we overrating the idea of using eye gaze as an input modality? I think Enkelejda also mentioned that it's a biosignal. So isn't there also a huge gain if we observe a user's eye gaze over a longer period of time? Because we maybe have an estimation of mental health. We maybe have an idea of the degradation, maybe also that I, as a human, maybe should take a rest. So I think I can imagine plenty of opportunities that, for example, relate to my long-term health. So are we well, let's say, be a little bit critical, putting too much effort into, well, we need to make this eye gaze-based interaction work, which seems to be very difficult, rather than it's understanding it as a very exciting biosignal that says something about me, for example, about my personal health status.
Can I chip in? It's not either or. Both are absolutely desirable and are fantastic and important research opportunities. The eye is a fantastic resource for supporting health monitoring. Yeah, so eye movement is already used for in the form of kind of specific tests for specific conditions. So that exists, and to make that more available as something that people can that can support people in everyday life, that's you have an eye test while you watch TV, kind of, is that makes absolutely sense. But I don't think that we should focus any less also on leveraging eye movement for interaction, because it's the movement of the eyes is there. We use our eyes during our interactions, and so far we're just not utilizing the potential it has for making interactions just a bit more streamlined, or there's so much, how the eyes are coupled with manual interaction is just fascinating, and the eyes can literally extend the reach of our hands, and I find that really fascinating for the design of new interfaces.
Okay, yeah, thank you.
Okay, Heike, can you put Louis on? He has a question which he wrote in the chat, but he's happy to read it out.
Yeah, hi. Thanks for the conversation. It was very interesting. I have a question that's directed primarily to Enkelejda, but Hans, feel free to chime in. And the question really is, do we need features to get something useful out of gaze data? Clearly, when we're doing basic science, it's been very helpful to define what we're getting out of eye trackers in terms of features like saccades, fixations, etc. That's either physiologically or psychologically defined, right? So dwells would be psychologically, operationally defined. Fixation, saccades, arguably, that could be physiologically defined. But with the trend moving towards machine learning or prediction systems the way it is these days, are we prematurely filtering out the interesting stuff from the data by feature labeling? So what's your take on this, or what do you think would be a very constructive approach towards predefining or not defining based on your own work in your lab?
Hey, Luis, thanks for the question. That's a very good question, because we have this deep learning era, right? So we are basically able to get something end to end without having even extracted those features. So so just my personal take on this. So what we do is, because I work a lot in this line of cognitive systems, and I like to rather have a theoretically driven view on the things rather than just a finalized prediction, for example, or detection. But rather, just like I like to work at this feature level, just because it helps you to align the results with what all of the work coming from the cognitive science and psychology that has been done for years or even centuries on understanding how we humans operate, so we can align our results and see also if they make sense at all, what we find out in our studies. in a rather theoretically driven manner. I know there's a lot of work, just like in image processing, done end to end, and like coming from these approaches where you even try to learn autonomous driving in an end-to-end fashion. I know there's an incentive for doing so with eye tracking data, but I personally, I don't find it useful, because it takes, there's a lot of things that you can do, but there's a lot of things you cannot do, taking some end-to-end approaches. I think that it is important to think at this feature level to see, are the results that we get in line with all of the theory that is coming from the cognitive science on this perspective?
So one limitation, you are somewhat preaching to the choir, because I'm a psychologist by training, right? So, but one very clear limitation, if we deal with features, at least the way it is right now, is that we think of features at the most primary unit in terms of fixations and saccades, or we still are. As we try to deal with more complex tasks or more complex behavior, it could be that we need to see, we need complex features as well, like chains of fixation, saccade. So how do you see these higher order derivatives emerging out of these very zero order features with regards to machine learning?
Yep. So what we do is indeed this thing, right? So we combine features at very different levels, starting from the zero level features. So I call them the zero level feature, the fixation, the saccades, and the smooth pursuits. And you can also have micro saccades depending on the eye tracking quality that we have. And it would be, a pity to actually get rid of the temporal information or any sub-pattern. So that's why we do a lot of sub-pattern analysis and include that in our machine learning models. Why? Because it's just natural, right? When you read, you have the set pattern. So why to not take this kind of sub-patterns that you have that are task specific or might be user specific, context specific, and use them in your model? But again, for as long as we don't really have nice explainable deep learning models that are able to, where we as users are able to go back and forth and see, okay, what are the explanations, right? What does the model do this prediction and why? Then we have to work on machine learning models that operate at these features, and features might be very complex features as well. That's no matter what kind of features that we have, but see it. Are they in line with the models that we have, with the theoretical models, and how do they align? So I think this is a very important question, because otherwise, Susanne just mentioned having eye tracking as a biosignal, for example, something that is telling about health, right? But I cannot go to a medical person and just tell him, okay, so this system will predict or has detected now something like a visual decline for a patient, right? The area of the visual field has gone worse, and the medical person would ask me why, and I'm not able to explain that. So I think you have to explain both to the users, and the user might be, the user that is doing the interaction, but also other stakeholders of such holistic systems using eye tracking devices. So that's why my take-in would be using feature-based approaches might be, a very convenient way to get around also with this issue.
I'd just like to add something, and then I'll hand the mic over. It's really interesting what you just said, because unless we actually know what the features really are, it might be premature to be discussing the topic of data security or biosecurity, because if we don't know what we need to reconstruct these sensitive data, the raw data is usually not sufficient. So I think, well, you just raised a really interesting point that triggered that thought as well. Thanks.
Yeah, thank you. And now, Mark, your mic will be on.
Yes, thank you very much. I have the question. I mean, nowadays it's very easy to get eye tracking data in virtual environments. There are a lot of headsets, VR headsets that have eye tracking capabilities integrated. So have you investigated, or how do you think about the, does this data generalize to the real world? For example, if you run an experiment in a virtual world to see how people react, where they look at, does this transfer well to the same experiment in a real setting?
Yeah, we've studied gaze shifts in virtual reality, and sort of in comparison with gaze shifts as they are reported in studies of, you know, in natural environments and so on in particular. So because I'm currently very interested in eye-head coordination in particular, and is eye-head coordination the same in virtual reality versus in real environments? And there are differences, of course, that we have sort of wider periphery in real life. There may be display effects and so on. So I think there are effects currently still, partly because of limitations of technology, but we have seen that some effects that have been observed in real life eye-head coordination are also present in virtual reality. For example, individual differences, that some people have a tendency to achieve gaze shift by turning their head more, and others have more tendency to keep their head still and rotate their eyes further in their head. Yeah, so that's there seem to be different tendencies, and they are as much present in VR as in real life studies. So,
do you think the content also plays? I mean, obviously to some extent it plays a role. Like if I think about playful activities with more engagement and so on, does this is this also the difficulty in interpreting this data, or is it like, does it work? Have you tried like VR games versus like serious environments?
Well, I mean, the content will always have an enormous effect. You know, sort of, are we talking about tasks where you know, that are more? There are many VR studies that look more at visual saliency and how we respond with eye and head movement to visual events. Yeah, but that is then again different from, say, visual search tasks where we're more goal driven. And I think we see the same basic mechanisms of eye-head coordination in VR as in real life, but I'm sure there are also effects, you know, display effects, like the limited periphery.
Yeah, I mean, I was thinking because in some games it might be more like focused activity. You know, this is a hypothesis. You know, because you have to. Depends on the task, of course, but if you think about like throwing games or whatnot, compared to just exploring an environment, but I guess it's the same. Like
it will be the same in a, you know, if you're in a real environment and have a focused task, you have a different visual behavior from kind of when you're just taking in the the environment. Yeah. So, but I think in principle, the environments are comparable in kind of the behavior they induce.
Okay, so we're getting closer to the end, and we have sort of the obvious question we want to ask. And I think I've got now a timer here that we really cut it to 60 seconds. And sort of the first question, you can decide who wants to go first, is if I want to do a PhD in that sort of fuzzy space of gaze interaction, gaze tracking. In 60 seconds, what should I do? And then you get an extra 30 seconds. what should I avoid? So I'm not sure who wants to go first. We go first with the positive things. What topic should I really go for if I want to now do a PhD on gaze interaction, gaze tracking? And then we do both of you 60 seconds, and I switch off my background that you can see the clock. And then, because I think that's very helpful. And then we, and you see here the clock, I switch it on. So who wants to go first? Hans has already a microphone open, so I think you can go first. And here's so 60 seconds. What should I do a PhD on if I want to do that?
Okay, you should do a PhD on how eye movement is coordinated with body movement. I think it's important to understand gaze as a multimodal activity that we don't just do with the eyes. So come and study with me in Lancaster.
I think that's a good idea. That's a brilliant idea.
What you should do is you should have an open mind and be ready to read a lot of psychology literature as well as design literature, because I think the really fascinating opportunities come from a deep understanding of the fundamentals of how we actually work physiologically and psychologically, and then bringing that to bear on new creative designs.
Okay, so we stopped that here. So you left some time. So this is sort of one PhD, and now we get another PhD. Enkelejda?
Yes, so hi, if you'd come to work with me right now, I would say that we would go into something that I like to call as interactive AI solutions, where we have the user in the loop and we try to make machine learning models explain their prediction and decision better by teaching them on how to incorporate also like eye gaze of people, right? So try to explain things like people would like to explain things. And also learn, how to predict better by using the most relevant features. And what you shouldn't do, I think that is very easy to answer. Do not try to build your own eye tracker any longer. So people always come to me with that idea. No.
I had a few people of those, and we even built one at some point because but interestingly, that didn't lead to a PhD. So that's an interesting. Hans, do you have sort of another thing besides not building your own eye tracker? What should people not do a PhD on if they do eye tracking?
Oh, what should they not work on? That's a difficult one.
I think that's also an answer. Yeah. I think that's if you don't build your eye tracker, everything else is okay.
Everything else is okay, yes.
So and if you throw some machine learning in, you get even a job, even if the eye tracking is not good. And I think with this, we are at the hour. And I thank both of our speakers, our guests, again. And thank you so much for being here. Also, thank you so much for the audience to come in with questions, to stay. And now we have an advert for next week, which is